Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora and in this video we are going to learn about chapter 4 of NCERT, which is quadratic equations. So in this video we are going to deal with the basic concepts of this chapter. Moreover, we will learn in how many ways we can solve a quadratic equation. So from the beginning, what is a quadratic equation? We had already learned about quadratic polynomials in the chapter of polynomials. So this is a quadratic equation in the variable x is an equation of the form ax square plus bx plus c is equal to 0, right? So we had learned that in a polynomial, if we have ax plus b, this is called a linear polynomial, and equations of the form ax plus b is equal to 0. These are called linear equations in one variable. So linear means if it is a polynomial, it is of this form ax plus b. That means the highest power of the variable is 1 in that case. Such expressions are called linear. And when we have to make a polynomial into an equation, we use equal to sign and then write something on the right hand side so that it becomes a linear equation, right? So when we have polynomials and equation in which the variable has a power 1, the highest power of the variable involved in the question is 1. In that case, they are called linear polynomial and linear equations respectively. But when it comes to the term quadratic, see, ax square plus bx plus c. We had learned in the chapter of polynomials that this is a quadratic polynomial. That means when we have an expression or a polynomial in which the variable involved has the highest power 2, or we can say the degree of the polynomial is 2. This polynomial is called quadratic polynomial, right? And if we have to write a quadratic equation, this can be written as ax square plus bx plus c is equal to 0. So now this is quadratic equation. I hope this is clear now that whenever we are dealing with an expression or equation having degree 2, if this is an expression, it is called polynomial. Since this is an equation, this is called quadratic equation. And this is very important thing that a should not be equal to 0, because if a is equal to 0, you can see that a is equal to 0 makes this term 0. Then we are left with bx plus c, which again becomes a linear expression, or this becomes a linear equation. So a is not equal to 0 is the mandatory criteria for this expression to be a quadratic equation. Okay, next we have, so in this question first we have to check whether these are quadratic equations or not. So by just looking at this power that this will open up with the x square, don't say that this is a quadratic equation. Whether it is quadratic or not, we have to work it out and bring this expression into the simplest form. So here we start with this. I had told you whenever we have an equal to sign in an expression, this is already an equation. So always start with this implies that sign. Open this bracket. This is a minus b whole square. So we have a square plus b square minus 2ab. X square plus 1 minus 2x plus 1. This is plus 1. Now we solve it further. Bringing all the terms to the same side. This becomes minus 2x plus 2, and bring this minus 2x here and plus 3 on the left hand side. So this becomes x square minus 2x is minus 4x. 2 plus 3 is 5. So after simplifying the whole expression, we have got this as x square minus 4x plus 5 is equal to 0. We can see that coefficient of x square is not equal to 0. It is 1 in this case. And since we have the highest degree 2, this is a quadratic equation. right? This is a way to analyze this. This is the second part. In this we have two expressions on both the sides of the equal to sign. So we simplify this, open this bracket. So we get x square plus x plus 8 is equal to, here we have x square, then we x multiplied by minus 2 is minus 2x plus 2x, and this is minus 4. Or you can simply use identity as a plus b a minus b. So this becomes x square plus x plus 8 minus x square. These two get eliminated, plus 4. Now we have brought everything to the left hand side. X square and x square is getting reduced. So we have x plus 12 is equal to 0. So this is the final value of this expression when we have solved it further. So you can see that in this the highest power of the variable here is 1. So since there is no term involving x square in this expression, so we can say that this is not a quadratic equation. This is not a quadratic equation, right? So this was the conceptual question. Next, we had learned in the chapter of polynomials that every quadratic equation has two zeros. That means whenever we have to solve the zeros of a quadratic equation, zeros means solutions or root of that equation. So what is the criteria? X is equal to alpha is a solution of the quadratic equation or root of the quadratic equation if alpha satisfies this relationship. Right, this is the basic quadratic equation. This is the format of quadratic equation. Now compare this. See what we have done. Here ax square becomes a alpha square plus bx becomes b alpha plus c is 0. What do we understand from this is if a number has to be a root or solution or 0, root, solution or 0, all mean the same thing, right? Don't get confused. Root, 0 and solution. So when we in class 9th you had learned that whenever we have to check whether this particular x is a solution or 0 or root of a polynomial, we always use to put that number in this expression, and if it becomes 0, that means this is the 0 of this polynomial. So simply what we have to do is we have to replace the value of x by that particular number. See, this is ax square. At the place of x, we are putting alpha here. We are checking whether x is equal to alpha is a 0 or not. So, replacing x by alpha, we get a alpha square plus b alpha plus c is equal to 0. So, if this makes the LHS and RHS of this equation equal, then we can say that x is equal to alpha is a 0 of this solution or root of this solution, or you can say solution of this solution equation, right? So what we have to simply do is we have simply to replace x by alpha, and if in that case LHS and RHS become equal, we can say that particular value is a 0 of that quadratic equation. Next, we can practice a question. Find the roots of the equation. This 2x square minus 5x plus 3 is equal to 0. Now to find the roots of a quadratic equation. See, in linear what we had to do is like 2x plus 3 is equal to 2. So we used to do solution of linear equation like this. We have to find the value of x. This is the only value here on the left hand side. This is 2 minus 3 is minus 1. So value of x comes out to be this. This is the 0 of this equation, right? So since this is a linear equation, so it will have only one root, right? See, here this is a very important point, that if any equation has as many zeros as is the degree of that equation. So in case of a linear equation, the number of zeros is only 1. Since the degree of this equation is 1, it will have only one root or one zero. So that we could find by solving this linear equation we had learnt in junior classes. So this is 1 degree 1, so it has one zero or one root. Now in this case we have quadratic equation. Quadratic equation means degree is 2, so it will have two zeros or two roots. Now how to find them, right? So this equation can be solved. This cannot be solved this way because we cannot bring this 3 to this side because we have x square term as well as x term. For this we need to factorize the left hand side of this equation. You have learnt about middle term split method, or we can make the whole square if it is possible. Here it is 2, this number is not a perfect square, neither this is a perfect square. So middle term split is the method we have to use here. Middle term split. For middle term split, if you remember, this is the first term. First of all, this expression should be in the standard form. The first is x squared, then x, then constant term. Now you have to multiply first and the third term. So you have 2x square multiplied by 3. Both are positive, so you get 6x square. The product of the two numbers is positive 6. So that means you have to break down 6 into two factors such that their product is plus 6 and their sum is minus 5. This number added to this number is minus 5. So start looking for the factors of 6. Factors of 6 are 6 and 1, right? So if you multiply them, one more thing, that since the product is positive, so either both the numbers are positive or both the numbers are negative. Only then we can have a positive product. Now we check the sum. Sum is negative. That means both the numbers have to be negative. So if I take negative 6 and negative 1, I get product 6, but the sum becomes minus 7. Another pair is negative 2 and negative 3. The product of these two numbers is plus 6. And when we add them, we get negative 5. So this is the perfect pair. We can break the middle term into these two terms. 2x square minus 2x minus 3x plus 3 is equal to 0. Take out common from the first two and common from the last two. 2x is common to first two terms. After taking them out, we are left with x minus 1. In the last two terms, we have negative 3 common. So when we take out minus sign outside, sign of both the terms get reversed. This term becomes positive and this becomes negative. So now we have x minus 1 common. And after taking it out, we are left with 2x minus 3 is equal to 0. So this is the factorization of the expression in this equation. Since the RHS of this equation is 0, that means the product of these two factors is equal to 0. Now what we can conclude from it? If the product of two numbers is 0, that means either x minus 1 is equal to 0 or 2x minus 3 is equal to 0. So the value becomes x is equal to 1, or in this case 2x is equal to 3 and x becomes 3 by 2. So these are the two zeros. Since the degree of this equation is 2, we have got two zeros or two roots of this equation, right? Next we have find the roots of this equation. Another example is 3x square minus 2 root 6x plus 2 is equal to 0. So here we follow the same method. First of all, it is in the standard form ax square plus bx plus c. So we take the product of the first and the third. 3x square multiplied by positive 2, we get 6x square, right? Now the product is positive 6, and we need a sum of negative 2 root 6. Here is the root thing. So what we have to take care of is we need root 6, square root of 6. Square root of 6, and square root of 6 is a factor of 6. How can we get it? 6 can be written as root 6 multiplied by root 6. Right? In terms of root 6, this is the only factorization that we can have. Because otherwise, if I take 2 into 3, we will get either root 2 or root 3. But we require root 6 in the factorization. So this is the only factorization that we can have. So how can we write this? And since the sum is negative, so both the factors have to be negative. That means we can write this as minus root 6 minus root 6. So we multiply minus root 6 into minus root 6, we get negative, negative, positive. Root 6 is 6. The product is 6, so this is satisfied. Moreover, if we add these two numbers, negative 6 is negative 2 root 6. So this pair actually satisfies both the criteria. So we break up negative 2 root 6 into negative root 6x and negative root 6x. So what is common to first two terms now? Here we have to be careful, like we require root 6. Now root 6 can be broken down into, since root 6 cannot be taken out from 3, what we can do is we can write root 6 as root 2 multiplied by root 3x, and same way we can write it here. Now how does it help? First of all, I have written prime factors in terms of products. So here also 3 can be written as root 3 into root 3x square minus root 2 into root 3x. Here we have root 2 into root 3x plus 2 can be written as root 2 into root 2. So this is the detailed version of all the factors of every term. Now we have to look for common. See, here root 2, second term has got root 2, but first term has got only root 3. So root 3 is common. Here we have 2x and 1x is common. After taking out common things, remove this root 3, we are left with 1 root 3 and 1x at the first place. This we have already taken, so we are left with root 2. I hope this is clear. Children find this topic bit difficult, so it's better at the initial stages you can break down all the factors of the root terms and then take out common. Now in the next two terms, root 2 is common to both the terms, and since we have minus sign, you can take minus root 2 common. After this, when we close the bracket, the sign of both the terms get changed. Minus root 2 I have taken common, I am left with root 3x, and the sign of this term is reversed, so we have only root 2 here. So root 3x minus root 2 bracket is common to both the factors. After taking this common, I have root 3x minus root 2. You can see that both the brackets are same, right? So now equating this to 0, we get root 3x is equal to root 2. Here also root 3x is equal to root 2. So we can say x is equal to root 2 by root 3. And from the second term also x is equal to root 2 by root 3. right? This is the prime factorization is on the, factorization is on the left hand side, and after equating it to 0, we have equated both the factors to 0 to get the values of x, and both the factors are same. So you see, if you are a very important thing that in this case both the factors are same, but generally children do one thing, that if they are getting the same factor they write it only once, which is wrong. Since the degree of this equation is 2, factors or zeros will be 2 in number. If they are repetitive, even if they are repetitive, you have to write it. You have to write both the factors, even if they are different or even they are repetitive. So the two factors are same, the two zeros are same, and both are root 2 by root 3. And since we have two zeros, you have to write it twice, right? The next topic is about the nature of roots. So the previous method was prime middle term split method, or you can say factorization method. Factorization we have already studied in class 9 also. This is something new here in the class 10. Nature of roots. Nature of roots is, if this is the quadratic equation, this is a standard form of quadratic equation. A is the coefficient of x square, b is the coefficient of x, and c is a constant term. So if this is a quadratic equation, then the value of x can be given as minus b plus minus square root of b square minus 4ac upon 2a, right? So this is a formula for the values of zeros. Zeros, this is called discriminant method or Sridharacharya rule also. So this is the formula that we have got, and you have to use this formula to find the roots of the given equation. So before finding roots, first of all, by this method, we can find the nature of roots of any quadratic equation. And how can we do that? Let us see. A quadratic equation ax square plus bx plus c is equal to 0 has two distinct real roots if b square minus 4ac is equal to 0. So there is a special term which is assigned to this value. B square minus 4ac. B square minus 4ac is called the discriminant of this equation. This is a particular value assigned to a particular equation with having a, b, c as the coefficients of x square, x and constant terms. So by using this ABC, a, b, c, we can first calculate the value of b square minus 4ac. Now if b square minus 4ac, that means discriminant, is a positive real number, d is greater than 0, positive number, then we can say that the equation will have two distinct real roots. That means the number of roots will be 2 and both of them will be real and they will be having different values, right? Next is two equal roots. If b square minus 4ac is equal to 0. In case the value of discriminant comes out to be exact 0, in that case, the roots are real but they are equal. Like in the previous case, we had, see, this was the case of, here we had two different values of x. So in that case, that we can say that the discriminant of this equation is a positive real number other than 0, right? In the second case, we had repetitive roots. That means in this case, d will be equal to 0 because there are two roots, real roots, but both of them are equal. They are equal to each other. So in that case, d comes out to be 0. And the third one is if the value of discriminant, that means b square minus 4ac is negative. If d is negative, that means there are no real roots. The roots in this case will be imaginary, and that we will be dealing in class 11. You will learn complex numbers in continuation from this topic, right? So right now we are concerned with the nature of roots. So in that case, find the value of d by this formula. D is equal to b square minus 4ac. So you can say if it is a real positive number other than 0, then we will have two different real roots. And if the value of discriminant is equal to 0, it means we have two real and equal roots. And finally, if d is less than 0, then there are no real roots at all. And now if you have found the nature of roots, in these two cases, if you are told to find the roots of that equation, you can find the roots by this formula. So you know the values of a, b, c from the equation, and this plus minus sign show that we will be having two values, one with the plus minus b plus root d upon 2a. This is nothing but d inside this root. And the second one will be minus b minus root d upon 2a. So these are the two values of x, or two zeros of x, two zeros of this equation that will be the values of the roots, right? So now we can practice a question. Find the discriminant of the quadratic equation 2x square minus 5x plus 3 is equal to 0. So comparing it with the basic equation, be careful about the signs of the numbers. Ax square plus bx plus c is equal to 0. We can say that the value of a here is 2. The value of b, see, here we have plus b and here we have negative 5. So b is equal to minus 5. And the value of c can be seen here as positive 3. Now b square minus 4ac, b is minus 5 square. Minus 4 into a is 2 and c is 3. So this becomes 25 minus 4 3s are 4 2s are 8, 8 3s are 24. Since the value of d is equal to 1 is greater than 0, that means the equation has two real and distinct roots. Distinct means two different values of the roots. Distinct roots. I hope this is clear. This is quite easy. This topic is very easy regarding solving the quadratic equations. Next is find the discriminant of the quadratic equation. Here the equation is 3x square minus 2x plus 1 by 3 is 0. So comparing it with the basic equation, now we can say that a is equal to 3, b is equal to minus 2 and c is equal to 1 by 3. So the value of d becomes b square minus 4ac. b here is negative 2 square minus 4. A is 3 and c is 1 by 3. So finally we have minus 2 square is 4 minus 4 times 1 is 4, that is 0. So the value of d is 0, therefore d is equal to 0. Therefore equation has two real and equal roots, right? So this is all about finding the nature of roots, and if we have to solve them further, then you can use the formula x given in the previous slide. So this was about how to find the nature of roots of a quadratic equation using the discriminant. I hope this method is clear, and this is quite easy in calculation too. So using this method, we will be solving further questions in the next videos. I hope this video was helpful in getting the concept of this chapter cleared. So if you liked watching this video, please subscribe, like and share it with your friends. Thank you.